Have you ever wondered what waits beyond the edge of our solar system? Beyond the planets, beyond the fading influence of the sun, there is a region so dark and remote that almost nothing from Earth has ever reached it. It is a place where silence stretches for billions of kilometers and only a single human-made explorer continues its lonely journey. That explorer is Voyager 1. Launched by NASA in 1977, Voyager 1 was never designed to travel forever. Its original mission was simple compared to what it has become today. Scientists wanted close-up views of Jupiter, Saturn, and their remarkable moons. The spacecraft completed those goals with incredible success, revealing giant storms, volcanic worlds, and breathtaking rings that transformed our understanding of the outer solar system. Most missions would have ended there. Voyager 1 did not. Instead, it kept traveling farther than any spacecraft in history. Decade after decade, it crossed the invisible frontier where the sun's protective bubble gives way to the vast ocean of interstellar space. Today, it is billions of kilometers from Earth, carrying a golden record filled with sounds and greetings from humanity while continuing to send faint radio signals back home. Those signals take more than a full day to reach Earth. Every message travels at the speed of light across unimaginable distances before being captured by NASA's Deep Space Network. That alone is extraordinary. But in recent years, Voyager 1 has faced a series of unexpected technical problems that challenged engineers around the world. In 2022 and again in 2023, mission controllers noticed that some of the spacecraft's telemetry data no longer made sense. The engineering information arriving on Earth appeared scrambled, almost as if Voyager had forgotten how to describe its own condition. Yet strangely, it continued operating normally and responding to commands. How could a spacecraft report impossible data while still carrying out its mission? Engineers spent months investigating the mystery. Eventually, they traced the problem to a malfunction within the spacecraft's flight data system, a computer responsible for packaging engineering information before transmitting it across deep space. Considering Voyager 1 is nearly 50 years old, many experts viewed the malfunction as a reminder of just how remarkable the mission has become. Unlike modern spacecraft, Voyager cannot receive software updates through high-speed internet. Every command must be carefully written, transmitted across billions of kilometers, and then executed by computers built with technology from the 1970s. One small mistake could permanently end communication. Despite these enormous challenges, NASA engineers managed to restore much of the lost data through creative programming and careful testing. It was an engineering achievement that amazed the scientific community. Still, Voyager's age presents new challenges every year. Its power source slowly weakens as its plutonium fuel naturally decays. To conserve electricity, mission controllers have gradually switched off scientific instruments one by one, extending the spacecraft's life as long as possible. Every remaining instrument now represents a precious window into a region of space no other spacecraft has explored. Beyond the heliosphere, Voyager measures charged particles, magnetic fields, and cosmic radiation that help scientists understand the environment between the stars. Each new transmission provides valuable information about a place humanity cannot yet visit. But the deeper Voyager travels, the more mysterious interstellar space becomes. Scientists continue studying subtle changes in magnetic fields, energetic particles, and cosmic rays that behave differently beyond the sun's protective influence. Every new observation raises fresh questions about the invisible structure surrounding our solar system. Is interstellar space smoother than expected? Or are there hidden boundaries still waiting to be discovered? The answers may arrive one faint signal at a time. And perhaps the greatest mystery is not whether Voyager will find something unexpected, but whether humanity will still be listening when it does. For nearly half a century, Voyager 1 has continued its incredible voyage into a region that remains largely unexplored. Every signal it sends gives scientists another small glimpse into the environment beyond our solar system. Although the spacecraft is aging, its discoveries continue to shape our understanding of deep space. One of the biggest challenges facing Voyager today is distance. Its radio transmissions have become incredibly weak after traveling billions of kilometers across space. By the time they reach Earth, they are far fainter than the energy produced by a household light bulb. Detecting these signals requires enormous radio antennas and extremely sensitive equipment. Even then, communication is far from instant. A command sent from Earth takes more than 23 hours to reach Voyager. Another 23 hours pass before scientists receive a response. Every adjustment to the spacecraft demands patience, precision, and careful planning. Despite these limitations, Voyager continues to return valuable scientific information. Its instruments have revealed that interstellar space is far more dynamic than researchers once expected. Powerful cosmic rays constantly stream through the galaxy, while invisible magnetic fields stretch across unimaginable distances. These measurements help scientists understand the environment that future interstellar missions may one day encounter. As Voyager ventures farther into the darkness, many questions remain unanswered. How far does the Sun's influence truly extend? How does our solar system interact with the surrounding galaxy? And what surprises might still lie ahead? These are real scientific mysteries, but they have also inspired countless theories. Some people imagine that Voyager could eventually encounter unknown cosmic structures. Others wonder whether it might pass through regions unlike anything previously observed by human instruments. Science fiction often goes even further, imagining contact with advanced civilizations or mysterious signals hidden in deep space. So far, however, there is no verified evidence supporting those extraordinary ideas. NASA has never announced that Voyager detected alien technology, mysterious coded messages, or impossible objects beyond known physics. Most unusual readings recorded by spacecraft can usually be explained through engineering challenges, aging hardware, or natural cosmic phenomena. Even so, the mission remains fascinating because reality itself is extraordinary. Voyager is carrying humanity's first message intended for any distant civilization that might someday discover it. Attached to the spacecraft is the famous Golden Record, a collection of music, greetings spoken in dozens of languages, natural sounds from Earth, and images representing life on our planet. Long after Earth has changed, Voyager may continue drifting through the Milky Way. In tens of thousands of years, it will pass near distant stars. Millions of years from now, it may still travel silently through interstellar space, becoming one of humanity's oldest surviving creations. Whether anyone ever finds it is unknown. But its journey already represents one of the greatest engineering achievements in history. Voyager reminds us that exploration is not only about reaching destinations. It is about asking questions, pushing beyond familiar boundaries, and discovering that every answer often leads to an even greater mystery. Perhaps the most remarkable part of Voyager's story is that it continues today. Every faint transmission received on Earth connects us with a spacecraft launched before the Internet, before personal computers became common, and before many of today's scientists were even born. That tiny spacecraft still speaks across billions of kilometers, proving that human curiosity can travel farther than anyone once imagined. As Voyager disappears deeper into the galaxy, one question remains. What will be the next discovery waiting beyond the edge of the known universe? Only time, and the quiet signals from deep space, may reveal the answer.